Hello and welcome to Chapter 5. Today we're going to talk about IPSs and IDSs as well, the intrusion prevention system and the detections as well. And there are three sections that we're really going to take a look at. We're going to take a look at the technologies, the IPS technologies, the signatures, and how do we implement IPSs on our routers. So our router is going to act as an IPS. All right, so let's get started. The first thing we need to talk about is something called the zero-day attacks. Zero-day attacks is when a hacker creates an attack right now, today, this minute, where no one has a solution for it. And so therefore, if that zero-day attack has been deployed, no one will be able, no firewalls, no one will be able to, no one will be protected. So an IPS setup will be able to detect, for example, that this is an anomaly, and therefore it will not allow any of the packets to go into the network. So having an IPS will most likely mitigate against this type of attack. Okay, so what an intrusion detection system does is it detects for patterns and to see if there's a pattern of attack that is occurring. So one way to do it is to actually set up a sensor that is connected to the switch. So all the data that comes into the network will also be sent to the sensor. And if it detects a pattern of uh, an attack, it would immediately send a trigger either to a firewall to tell the firewall to stop to stop the attack from happening. Otherwise, the data will just go right through. So this is an IDS system. It really does not prevent; it'll just detect the attack. And the good thing about an IDS is that or it does not really hinder any of the traffic that's coming into the network. It just makes a copy and it's analyzed. But the problem is if it detects an attack, it's already probably into the network already. That's the issue with an IDS. So most people really don't bother using an IDS. They use an IPS. An IPS is placed in line of the network. So if there is an attack that's been detected, it immediately can be stopped from coming into the network. The disadvantages on this end when you have something that when the sensor is in line is sometimes it creates some sort of a delay, but that's okay. It's still worth it. Mostly that's why we call this an IPS. It prevents the attack from happening once it's detected, of course. All right, so both are use sensors. It all depends on how you apply them. Do you apply them in inline or promiscuous mode, where you can be, connected to the switch? That's an IDS. An IPS usually is connected in inline. They both use signatures to detect patterns. A signature is really a set of rules, just like an antivirus program has definitions, we call them. A set of rules that are, and if there's a pattern that matches one of the signatures, bingo, that will immediately triggers um, an alert, for example. You can detect atomic patterns, which means one packet at a time. If one packet has a specific signature on it, that will immediately trigger it, or multi-packet, a group of packets coming in. So that's called a composite pattern. So it can detect either one packet at a time or a group of packets. Both IDS and IPSs will do that for you. All right, so here are the advantages and disadvantages of a detection system and a prevention system. So please write those down. So that's one thing that I want you to submit. All right, we've discussed this already. The IDS is because they are attached inside the network and not in line. They don't have any impact on the traffic. But on the other hand, once an attack has been detected, it's already in the network. Uh, And IPS is inline is a much better, but it also again it slows down the network, the traffic from coming into the network. All right. So there are two different types. There's host-based and network-based. So what we are talking about just previously was the network-based IPSs. That you definitely want that set up in front of your network. Just know that the NIPS, they call it, the NIPS, uh, it does not or cannot examine encrypted traffic. So if you have a VPN set up and then you have the VPN appliance and then you'll have the IPS right after it, all the data that goes into the IPS will not be examined and it will go right through. So you have to unencrypt the data before you send it to the IPS. All right, so you got to be very careful. The good thing about, so if you do that, then what you need to do is you need to have a host-based IPS, and the host-based is a software that is loaded on the local machine, and that will provide you with protection to a specific host, the operating system and the applications. Uh, of course, that HIPs we call them, the host-based IPSs, they only they have to be installed on all the machines locally, of course, but then they have no overview of what's going on the network. So if you have a NIP and a HIP, that's probably the best way to do it when it comes to the prevention systems. All right. In the network based, so you want to definitely have a sensor in here for your DMZ zone. You're going to have a sensor that's coming inline into the network and another sensor also set up afterward inside the network as well. So, and by the way, these could be set up on the wire, but you want your own separate appliances that do that because there's a lot of analysis that happens. All right, these are the different types of appliances that Cisco offers. How do you choose an IPS solutions? You have to decide on, well, you have to know how much network traffic you have, how busy you are. So you have to do an analysis of a whole network traffic wise, maybe using an SNMP, how your network topology is set up, how much money you're willing to spend, and do you have enough staff to really manage the IPSs? Because sometimes if there is an attack, you need to analyze what the attack is and what they were trying to do. Maybe you have to set up a honeypot, which we'll talk about later on. So the staff sometimes are you need student bodies. I was going to say you need administrators or junior administrators to analyze a lot of the alerts that occur. Although it could be set up to automatically trigger alerts and trigger, the firewall to set up ACLs to automatically stop an attack from happening. But you need to consider all of these, how much traffic you have, the network topology, the setup that you got, of course, the money that you're going to spend on the appliances, and even the staff themselves. How much people do you have to manage those IPSs? All right. Here's another thing that I want you to write down, the advantages and disadvantages of having a NIP. Okay, so I think we talked about that. And the way you can set up, this is called an IDS, setting in a promiscuous mode. That means it's not in the inline traffic. The data has to be copied. If this guy wants to send data to this PC, he'll send a copy to that PC, but also another copy will go to the IDS for analysis. If you're going to get an IPS, it has to be placed in the inline mode where the data is analyzed before it's sent anywhere. All right, if you are going to set up an IDS, then you have to create what's called port mirroring well, this is a hop on the switch itself. You create a port mirror, which means any data that is passed on the ingress coming into the switch, not only will be sent to the destination, but another copy of it, mirrored copied, will be sent to the packet analyzer. In this case, it would be our um, IDS, or you can have a packet analyzer such as Wireshark or just any type of sniffers that are out there. All right, so that's what the span ports are. The span ports, the network, the port analyzer, the switched port analyzers. You can set up the fast Ethernet as the ingress. This is going to be the outgress, but also this is going to be the destination port. So these two ports are going to be source span ports because when they send in data, a copy of them will be sent to the destination port, G01 in this case. That's where this IDS sensor is going to be set up. And how do you set up those ports? You just type in monitor session. You usually type in the number 1 and you say source fast Ethernet 01. So you type in monitor session 1 source FA0/1. And for the where the IDS is going to be set up, you type in monitor session 1 destination G00, for example. That's it. Simple as that. You just created a mirror ports. You set up the ports using you set up the span ports using the monitor session command. Okay, by the way, I do want you to type that in. So how do you set up a source port? You can type in the command monitor session 1 source. You could say FA01 and also type in monitor session 1 destination G00. That's where the IDS is going to be set up. I want you to know those two commands so in case and those do come up on the exam, asking you how to set up a switch for span. All right, now let's talk about the IPS signatures and how to manage them and understand how they work. And then later on, we'll be able to implement them on the router itself. All right, a signature, like I said to you earlier, please write this down also. We need to know what a signature and their attributes are. The signature is a set of rules that an IDS and an IPS use to detect a typical pattern or intrusion activity. So they have three distinct attitudes, different types, the triggers, what triggers them, and what action to take. Okay? And there could be either, we also talked about the atomic and the composite signatures. You can, a signature could be just per packet or a group of packets, composites. Okay? So please write that down as well. The categories of the signatures, the atomic and the composite, and the definitions of each. All right, the signature file. The signature file can be downloaded from Cisco. So this is like updating your antivirus. All right, because these signatures changes and the antivirus programs. If you have an antivirus program installed on your computer, and typically it's always connected and it uploads the definitions, the latest viruses that have been detected, it goes into your file. So anytime you want, when it scans your computer, it's going to compare it with all the definitions that is installed in the antivirus programs. And these definitions are always being updated. Same thing with the IPS signature file. The signature file has all the threats, all the different types of network attacks that are occurring, and it's constantly being updated. But the thing is, you have to go and download the latest file that has all the different types of attacks that are all threats. So you got to go to Cisco and download them. So when we do our lab, I'll have to give you those. We'll talk about that later on though. So the signature file is a new threats identified, new signatures must be created and uploaded into the IPS file. Okay. There are micro engines. There are the signatures that example simple packets, and some of them may examine the different services, a string, multi-strings, or others. So these are the micro engines that a signature may have. You can pick and choose. I mean, if you can actually go and the simplest way is just to do atomic or maybe just atomic. Just do it as just examine packet per packet, right? instead of doing services or something else that may take more time and may slow down the actual analysis. Okay, the different alarms that are signature alarms. I definitely want you to write these down. Um, the advantages and disadvantages of the four different signature alarms that are out there. There's pattern based, and you have to set those up, by the way. Pattern based really means it's simple, just looking for a specific pattern. Excuse me. So, known specific patterns that are out there, and I'll have all the signatures for those patterns. So, if you detect a pattern of an attack, you immediately trigger an alert or stop the attack from happening, depending on the pattern. Anomaly based is really another way. You have to create a profile first, so you really need to know um, what's normal first. So you create a what's normal traffic, and that may take a little time setting that up. You need to run your network and find out what's a normal traffic. Maybe an anomaly is no traffic should be at 2 o'clock in the morning, or no traffic that somebody sends more than 500 packets at once, or no normal traffic should be, if there's a tremendous amount of requests being sent to the printer, for example, or to a specific server, you can set a specific threshold that will say that this is an anomaly. So you have to set a profile first, and anything beyond that profile will be an anomaly and will immediately trigger um, an alert. That's a good way of doing it, but it takes time to really set a profile on what's normal. Policy based is really sometimes called behavior based. Uh, it can detect unknown attacks. So you can say, all right, and this is what can really prevent the 0-day attacks. So if you have a specific policy that only the following packets should be used. For example, no one is allowed to log in at 2 o'clock in the morning, no access to the network. So if your IPS detects something happening at 2 o'clock in the morning, it's against the policy and that will immediately triggers an alert. Honeypot based, what honeypot means is you create a network or even a server that's open for attacks. Of course, you don't want to connect it to your legit net LAN, and you watch for attacks and what the attackers are trying to access. And once you learn and know exactly what the attacks are, then you go and set up an IPS to prevent these threats. And of course, you take the honeypot offline. You don't just leave it attracting attacks, right? All right, so these are the four different signature alarms: the pattern-based, the anomaly, policy-based, and the honeypot. So please write down the advantages and the disadvantages of each. All right, so these are the examples that we talked about just a second ago. Okay, getting into the benefits of the Cisco iOS solution. So these are the benefits of having your own appliance instead of having the actual router doing the IPS for you. All right, the alarm triggering mechanism. There are four different types, and I remember when I took the Cisco security exams, I was definitely as I think one question came up on there. All right, the different types. When you are fine tuning your IPSs, you need to know that what you want is true positive and true negative. True, let's get those out of the way first. So when you see the word true first, it means it's good. True positive means uh, there is an attack and an alert was generated. We stopped the attack. So that's exactly how the IPS should behave. If true positive means there was an attack and it was stopped or an alert was generated. True negative means that normal user traffic from the network was passed through, was detected and it was passed through the IPS without being stopped, without an alert being generated. So that's exactly how the true positive and the true negative. That's exactly how your IPS should behave. False positive means there was normal traffic going through, but the IPS thought it was an attack and it stopped it, or an alarm was generated. False negative means there was an attack and the IPS didn't notice it, let it through. So that's no good. So you have to fine tune when you have those false positive and false negatives in the very beginning of implementing your IPSs. You're going to get a lot of those, your false negatives and false positives. So you have to fine tune till you're all okay. Okay. All right. So please write those down. I just want you to write the false positive, false negative, true positive, true negatives, and what they are. You can write this whole thing down if you can. It's probably best to create like a little um, table and write that down. You definitely need to know that. All right. The signature actions that you can take, you can generate an alert, logging the activity, dropping or preventing the driving or preventing the activity from happening. That's probably the best way to do it. That's what I would set the alert to happen. Don't just log it in or generate an alert. That doesn't help. You know, if you notice an attack, drop the packet immediately. You have to be in line. You can reset the TCP connections. If somebody hijacking your TCP connections, you can reset it. So he'll be, usually people tap into a connection that's already been set up. So when you reset the TCP, they'll lose that connection, right? Block future activity or allow the activity if you want. Of course, you don't ever want to do that. The best setup is to drop the attack, but then you have to get involved and find out, if that was a legitimate, if it, was it a false positive or a false negative. You have to take into event when you, especially in the beginning, when you're dropping or preventing the activity. But that's again the best way to set it up, to set up an IPS. Okay. Um, Moving on. Okay. Now, how do we manage and monitor the IPS? There are four different methods that you should consider. Uh, Management method, the event correlation, and staff, security staff, and the incident response plan. So, how are you going to manage the IPS, especially in the very beginning? Event correlations mean when there are attacks from different locations coming at the same time. That's why an NTP network, the network time protocol, should be set up where everything is timestamped so you'll know exactly where everything is coming from. The staff, like I said to you earlier, the staff needs, you may need additional hand when there is an attack to evaluate to evaluate the attack itself and how to respond to the attack. What do you do? How do you fine tune your IPS and how do you prevent um, other attacks from happening? Okay. Now, so that's the four. You can send your information to either a syslog server, the alerts, or to another server called the Secure Device Event Exchange, which have different parameters or different alerts that you can set up, or you can have sent to both if you really want to. Okay, so the best IPS configuration is to put one inline that comes into your network. And if this is your DMZ zone, just making sure it's set up um, to the firewall, right? So it should be in line before it goes into your network. That's where your IPS should be. Cisco Global Correlation means that Cisco will have just like antivirus programs that automatically connect to a website and download and install definitions. The Cisco Global Configuration has signatures that can automatically be downloaded into your appliance and without any problems whatsoever. And those signatures are constantly being updated, so you don't have to keep getting the file and installing it. So connected immediately to the Cisco IPS itself. Um, the Cisco intelligence operations. So this is a database that can have of all the signature IDs, the attacker of the IP. They can track all of this down for you. Okay. So it has the different reputations, the blacklists, it filters, all of that can be set up on your Cisco AS and it will automatically be done. So if you set up an ASA, um, it can filter out botnets, data distribution, DDS, DDoSs, all of that can be done automatically for you. All right, now let's talk about implementing the IPS. What do you do? There are 5 steps that you really need to go through. You're going to download the iOS IPS files in the lab. I'll give them to you. We're going to set up the configuration directory in the flash. We are going to copy the crypto key, configure it. I give it to you from the iOS files, and then we're going to type in the commands to enable the IPS on the router, and then load the signature file into memory at the end. All right, so I want you to write all of these 5 different steps, by the way. So download the IPS files. The first thing, well, actually, I'm going to give them to you, or you go to the Cisco site, but you have to have authorization if you're going to go to the Cisco to download the file. Then you make a directory. So type this in, make directory mkdir, and just give it a name, whatever you want, IPSDIR. Okay, so you made a directory in the flash, and there it is. Okay, it's called IPSDIR. Oops, sorry. Let me just go back a little bit. You can rename it, but make a directory. Okay, that's it. The second thing you're going to do, this is really the third step, is to copy the crypto key. So what you do, there's a file that I'll give you that you'll have in addition to the signature file, is you open it up. It's in Notepad. So you copy all of this and you go to config T and you paste it. And this is a show run will show you that the key has been copied, right? It'll be in the running config. The crypto key pub key change RSA. Okay, so you copy that. That should be given to you. All you have to do is copy it from the Notepad. All right, to enable the iOS is you create IPS name, give it a name, and then you also type in the command IPS config location. Where is it located? It's located in the IPS, and then you set up the the messages where they're going to be sent, the event notifications. We're going to send them to the SDEE, right? So first you set up the IP HTTP server, and then you say IPS, and you write in, well, it's actually right here. So after you type IP HTTP server, you type in IPS notify SDEE. So that means all the notification will be sent to this server, well, not necessarily to this server, or using this protocol. In this case, the server is really on the router itself. And then you type in IPS notify log, which means start the logging. Okay. So if you do not write this option, it says here that the alert messages are sent to in a syslog format. Okay. Otherwise, we'll use the SDEE format. Okay. So now, once that's enabled IPS, then you need to also type in IPS signature category. All signatures has to be categorized. There are 3 different types. There is the old, basic, and the advanced. So we're going to say, okay, we're going to do all the categories, and we're going to retire them. So all the categories are not going to be used, retired, excuse me. And then you take the iOS IPS basic, the basic one, and don't retire it. So the first thing is, because there are 3 different categories of these signatures, like I said, either basic, advanced or all or both. So the first thing you do is you retire everybody. That means don't use any of the categories. And then you unretire or retire false the basic one. So you're just only going to be um, in this case looking for the basic group, the basic signatures, okay, which takes less time to analyze. And then you go to the G00, all the incoming data is going to be, then you up, excuse me, just let me get a drink. Then you go to the interface on the router on the G00 and you say, all right, that's all the incoming data from the outside. And then you go and this is where you apply in the iOS IPS. And then you're going to apply it out on the, because on G01, more data can be coming in, but all the data should be out. This is coming into the network, coming in from the network. And this is also going out to the network. So data is going to be analyzed going in from both from outside and inside the network, and then all the data will be sent to the outside. Okay, so write those down. This is how you enable them. Oh God. Okay, moving on. And then the last step is you want to copy the actual signature file. So you got to put it on a TFTP and then call it from the TFTP to memory using this command right here. Oh God. So your TFTP, that's the IP address of your TFTP server, and that's the file, the signature file. So please copy that down. Okay, moving on. To retire and unretire signatures, you can use these commands. Any specific register signatures that you want to retire or unretire. This is to unretire. Excuse me. To monitor, you can use event action, or you can use any of these commands to verify iOS. And finally, report IBS alerts. You can use this command to do that as well. Okay, I'm sorry, I'm just getting I'm sorry. I don't know what the hell is going on. All right. Anyway, the last thing that I want you to write down is has to enable the SDEE. And this is really, I think we did that already. So you type that in. The only difference is how many how many events you want to be able to send. Up to 500 events, the buffer size. That's the maximum. And that's probably a good idea to do that on your router, because otherwise, if you just leave it, it'll just keep sending updates and overwhelm the buffer on the router, and your router becomes extremely slow. All right. And that's it. So write down everything that I told you and submit that as homework. And of course, we'll be able to, after we go through our packet tracer labs and in-class labs, the hands-on labs, hopefully you'll have a better grasp of how to set up an IPS. All right, until the next chapter, I'll see you then. Good luck.